Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have sine inverse of 2x divided by 1 plus x square. So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what our y is. So that's my y. I know that my y is not in a very simple format whose antiderivative I know from first principles. So I have a sine inverse and I have a 2x divided by 1 plus x square inside the sine inverse followed by dx, right? So I know that I do not have it in the integral of u dv pattern, but is there a substitution that I can make to simplify my y? And like we've solved in our earlier problems using inverse trigonometric functions, try to solve them using the method of substitution to start with. And I know that when I see 2x divided by 1 plus x square, I need to relate it to a trigonometric identity which I'm quite familiar with, right? And what is that identity? 2 tan theta divided by 1 plus tan square theta. What is that equal to? That's equal to sine 2 theta, right? That's the identity. Now, can I connect this identity with 2x by 1 plus x square? Yes, indeed, I can do that, but with the substitution x equals tan theta. And when I do this substitution, I see that my y expression will become a lot more simpler. My x equals tan theta, therefore my dx equals secant square theta d theta. Right now, I go back to my y and I apply this particular substitution into my y. What do I get? My sine inverse of 2x divided by 1 plus x square is nothing but a sine inverse of sine 2 theta, which is nothing but a 2 theta, because of a sine inverse of sine x is nothing but a x, and therefore sine inverse of sine 2 theta is a 2 theta, into my dx equals secant square theta d theta, right? Now I know that I can pull out the 2. When I say pull it out, I mean pull it out of the integral. And I'm left with theta secant square theta d theta. And you folks are quite familiar with this. In fact, we solved the same integral in my previous problem. So integral of theta secant square theta d theta can be solved using integral by parts because I have it in the UDV format. Integral by parts states that integral of u dv equals uv minus integral of v du. And when I solve for this, I will end up with a theta tan theta minus ln of secant theta plus c, right? And if you've not taken a look at my previous video where I have solved for tan inverse of 8x divided by 1 minus 16x squared dx, where we again solve for integral of theta secant square theta d theta, I'm going to put a link to that particular video in the description and I request you to take a look at it because I've solved for this skipping all the interim steps. And in case you're wondering how did I arrive at that, please take a look at that particular video as well. So now I go back to my y and I solve for my y, right? So I have 2 times theta tan theta minus ln of mod of secant theta plus c, right? So this is what I get. I know that I cannot leave everything in terms of theta because what I've been given is in terms of x. So I put back everything in terms of x. My theta is nothing but tan inverse of x and my tan theta is nothing but x. So then I come to the second part. I have a ln of mod of secant theta, right? So what is my secant theta in terms of x? I know that my secant squared theta minus tan squared theta equals 1, which means my secant squared theta equals 1 plus tan squared theta, which means my secant theta equals square root of 1 plus tan squared theta. So what is my square root of 1 plus tan square theta? It is nothing but square root of 1 plus x square, because the original substitution that I made is x equals tan theta, right? So my ln of mod of secant theta becomes ln of mod of root of 1 plus x square. And then I have my constant plus c, right? So the answer to this problem is 2 times x tan inverse of x minus ln of mod of square root of 1 plus x square plus my arbitrary constant c. I don't think I can do any further simplification. Let me highlight my final answer in pink. There we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.